Hi everyone. So I got the disadvantage of going right after we got to play with a lot of fun toys, and also after lunch, so everybody's probably falling asleep. So I will keep it I will keep it short and to the point though. A little bit about myself. My name's Chris Farnell. I am the test engineer and managing director of the INCREP facility. It's a 6 megawatt facility at the University of Arkansas. I've been helping out with FLL judging and stuff for about 6 or 7 years. And I have to say, I think robot design judging is probably the easiest judging because you have actual metrics and you can observe the metrics and things. They had me do some core values judging, and oh my gosh, like the abstractness of it all. It was hard for me to shift gears. But I'm just going to kind of go through this and go through a little bit about the design process, a little bit of what we look for in like very strong teams, and and honestly, just ask any questions you have as we go through this. So I should preface this with the disclaimer: I am not affiliated with FLL. These are my observations going through judging and everything with other robot design judges for the past 6 or 7 years, and this is just based on discussions we've had trying to figure out who's gonna be the best teams out of that room and all that type of stuff. But don't go to somebody and say, "Oh, well, Chris said this is the way to do it," because they're gonna be like, "Who's Chris?" So this is just a little thing that they had on the FLL website for design process, and I liked it. It's going through and it's saying, okay, well, you explore, you investigate, you see what your problems are, you imagine, you come up with solutions, then you can kind of create experiments and things like that. You test them out, see if those experiments work, and then maybe they work a little bit, where you go through a design iteration and make it work a little bit better. And you can kind of go through that iterative process, and that's a very nice little metric. I guess the only thing I would change from their website is just have a little loop that goes here along with the bigger loop. And then after you've done all this, then you want to share it. Somebody told me a long time ago that 50% of a scientist's job is communicating why what you're doing is important. And I think that really runs true for this as well. You can build a great robot. It could go out there and score 5,000 points, or whatever the max is, 300 points, 350 points. But if you're not actually able to articulate what design process you went through, you're not going to win the robot design portion of the competition. So, and the flip side of that's also true, just so everybody knows. We've had people that go through and they had a rock solid design process, and we're very, very impressed with them. Then they went out to the competition, and they might not have performed all that well for whatever reason. They might have had a sensor fail, they might not have calibrated something correctly, and they had really poor robot performance, but their design process was really on point. And so, hey, guess what? They still got that credit for going through all that great design process. So the two there is usually a correlation, but they're not dependent on one another. And correct me if I say anything wrong, Dr. Cassidy.
You know way more about robot design judging.
So again, I wanted to show the mission table, but we've already kind of went in depth on the mission table, so I can skip over that a little bit. Some things that kind of we expect you to bring, or that are very highly encouraged. I wanted to make sure I told you all this because people, even now after we've had our judge advisor tell people to bring certain things, and it's outlined in the documentation to bring things, we say, okay, this is great, you brought all this stuff, where's your robot? And they'll forget to bring their robot. They'll forget to bring their attachments. They'll almost always forget to bring their code. And so how can we really judge the code without seeing the code there? So some of the things we really want you to bring are the robot and attachments. If you've kind of documented the process, your design process, you can do that using something called an engineering notebook. And there are a lot of examples for that online. But bring that engineering notebook and show us, hey, you want to know what we did over the summer? Or you want to know what we did over the last few months? Here is a binder, well organized, and it shows kind of the design process. And this is the justification of decisions made. Bring your code. We want to be able to see that code. We want to be able to, we need to see that, you have comments and that it makes logical sense, and that the students can actually explain what's going on. That's one thing with FLL. The mentors aren't supposed to, we give the benefit of the doubt, but it's supposed to be the kids that are doing the work, not the mentors. And so if you have a piece of code we want to make sure the students actually understand what's going on and they can explain to us how they did the coding. And we also want to see like strategy printouts. So for that, and we're going to go more in depth this later on, but I'll share a few anecdotal things with you as we go through the rubric. But it's really important for us to know that you have a detailed strategy. You know, and going out there, some people say, hey, we just went and got the stuff that was closest to base. I mean, that is a strategy technically. It might not be a very involved, multi-domain, optimized strategy, but it is a strategy. But then we had this one group that built up this chart and like built up a matrix. And they said, okay, we weighted how close the missions or objectives were from base, but then we also weighted their difficulty level, and we weighted how many points they were going to get. And then they kind of ran through like a very basic equation and said, hey, these are the high value, the low-hanging fruit with high value points. And it was like, wow, you really thought about strategy. And then we had another group that came through and said, we did all this, but then we also incorporated pathing. So it was like, hey, we're already in the neighborhood and we have an attachment that can serve that. Why don't we go ahead and kind of, kill two birds with one stone, that whole idea. So I mean, to know that they've thought about it and they've kind of thought out that strategy is very important, and we want that communicated to us.
Yes.
Do you prefer, do you and your peers prefer printed code or laptop code?
Either way is fine.
Okay.
Sometimes it's nice to have a little printout, especially if we can like keep it. Because when we go back for deliberations, what happens is they have, maybe 9, 12 robot design judges, and we each get to see a fixed number of rooms. And then we have to all join up after the judging, and this happens with all the judging. We all join back up in the room, and we argue about like how awesome you all are, right? It's like, no, these people were super awesome. Well, these guys were super duper awesome. Well, then if we actually have like a printout of like an example of your code, we can be like, look at this. They're using my blocks, great comments. Look how efficient they did it. And it's like, yeah, you can't really argue with that. So I prefer printouts, but I don't think you're required to do either. As long as you have it, then that's all we really care about.
Thank you.
Oh, no problem. Other design, process and documentation. That's like, if you did have some kind of an iterative design for your robot or something like that, and you wrote some kind of documentation, please include that as well. We want to see the whole thing, right? The entire process if possible. And then suggested, this year we're part of a pilot program, and we're not going to have robot tables in the judging rooms, and so that's going to make it a little bit harder for us to kind of see what your robot's doing and what the intentions of the robot is. So I had some students last season. They came in and they brought in a couple of videos of their robot just kind of running missions. So I mean, that would be great. And it's not required, I don't think, but I mean, I think it really drives home what your intent was with the robot and the program and all that. Also, it's nice because you can wait for it to be perfect, right? You don't have to have that variability. You can do it on your own home table. Behavior expectations. So whenever we go in and we start talking to these students, we want to see a lot of interaction. We want to make sure they're engaged. We want to have, one example that I thought was kind of a poor showing on a team. They had one person that explained the whole thing. And it was great that one person was so involved and so excited, but that one individual student wouldn't kind of let her teammate get a word in edgewise. And it was obvious that they were a driving force, but they didn't ever kind of yield the floor to let anybody else explain it. So we don't want to see that. We want to see everybody on the team kind of get engaged and ask questions or answer questions. And we'll direct questions to different students. So like if I'm asking you about your robot design and you've answered 2 or 3 questions, then I'm going to start looking away and I'm going to start asking you more specific questions just so we can get everybody engaged.
Are you looking, typically though, I mean, there are a couple students who are far more.
There are, and we want everyone to, so in a perfect world, we would want everybody to know all aspects, because as they keep reminding us, it's not all about robot design. We have 3 things that we're judging on here: core values, the project, and also robot design. So we want the students to at least be able to engage at some level with the discussion. They might not be experts, and you see that a lot. You say, hey, Jim, was big on the coding, and Jane over here, she did a lot of the actual building of the attachments. But we want to make sure that they can all at least speak a little bit to each part of the project. Does that make sense? And so yeah, we want everybody to have a chance to speak. Another big issue is breaking into groups. So we want everybody to talk to us as a team. So a lot of times, in the interest of time, people will jump off and say, hey, these two students, they were the coders. We're going to let you break over here and explain the code to one of the judges. And then the other team is going to show you how the mechanical stuff works. We're actually trying to get away from that. So that did happen in the past, but now we're trying to make it so that everybody, we do it all as a group. No breaking off and segmenting. Everybody talks to us as a group. Again, everybody has a chance to speak. We want to make sure that you do yield the floor, that the students rather yield the floor and let all their teammates. And I've seen great examples of this. One example was, somebody answered a couple of questions, and we asked again, and they were obviously the leader of the team, right? They were obviously the most passionate about it, but they caught themselves and they said, hey, well, why don't we, hey, Jim, why don't you speak? Why don't you talk to him about this and tell them what we did here? So it's really great to see that yielding of the floor and letting everybody have a chance to interact. Positive attitude. We want to make sure people are having fun. People can be stressed out in situations like this, and but it's all about having fun. That's what we got to remember. So we try not to let anybody get flustered. Back when we had the robots running, we'd always tell them, hey, stuff happens. Light can change. The tables aren't set up to regulation and all that stuff. We'd make sure they knew that their most important thing was that they were having fun and being engaged in learning. And for mentors, we want to make sure that there's no coaching while you're in the room. So again, this is all about the students, right? This is all about what the students have done over the time. And we usually don't have a problem with this. Usually the mentors are really good about sitting back, the mentors and coaches sitting back and letting them do the things. But just so you know, we do want you all to kind of sit in the back and you can video and all that type of stuff. We don't want you all to engage during the questioning. All right. So any questions so far before I dive into the rubric? Everybody's still awake? All right. Put my phone down just so I can see. I got about 15 minutes to run through this. Well, so this is an updated rubric. So they kind of got me, my wife and myself. They said, hey, can you come over and talk to us about judging, how to be successful in the judging room? We were like, yeah, that'd be great. We'll come over in the next weekend and do this. And then they sent, like a couple of days later, I think it was, here's all the updated rules and rubrics. And it was like, oh, they changed a lot of stuff. And so this is the updated rubric, and it's only valid or only approved for use in select pilot regions. So I was just talking with Dr. Cassidy. He said he's already spoken to you all about this. And I think all around Arkansas, for the Arkansas competitions, we're going to be using this rubric. But just know, if you go to Oklahoma or if you go to some other place, then they might still be using the old rubrics. So you want to be aware of that.
So got the first Lego League thing up. It's not that rubric.
Right. So this is
Where do we get a copy of that one?
that would be a Dr. Cassidy question.
I'm sorry, I didn't hear.
Where can they get the updated rubrics?
That's a good question. I will verify, they will be emailed to all coaches as soon as Judge Advisor for the state says they can go out. Anything that, we're gonna share with you the slides that have been used today, and so just consider those officially unofficial until you get the filings.
Okay.
I think actually at the end I've attached mine, my rubric. This is a PDF file, so if you do share it, know that you're sending that PDF out with it as well.
Right, no, that's fine. I wanted them to, I talked to, so for those of you who are new, her name's Candace Rainwater. She's the judge advisor, not just for the state of Arkansas, but for the whole world. And so
Whole planetary system, right?
That's right, yeah, as far as we know, right? And so, so we're participating in this pilot, and so I talked to her about it this week. But so I have them on my computer. I just want her to tell me it's okay to send them.
Didn't you say that it's not actually, it's just a simplified scoring, right? Isn't all the components still the same?
So the components on the, so that's, I wish Candace was here to make sure I was right.
Well, so they did change it up. I see that I think you have less options.
So correct. So the So for those of you that are familiar with the old rubric used to have beginning, developing, accomplished, and exemplary.
Right.
And they had descriptions of what each of those meant underneath them. Exemplary is now just that plus. Okay, so now if there's a team that Chris thinks is exemplary in durability, then he just circles that plus, right? So they're a little less wordy, in my opinion, not enough less. I would like to see the rubric, because I think sometimes all the words on the rubric can tie judges' hands, right? Like on research under the project, it used to say to be exemplary, you had to have four different kinds of sources. And I was like, well, what if they only had 3, but they did a really phenomenal job? You know, so they're a little less wordy, and then on the core values rubric has fundamentally changed. Yep.
Thank you.
Mhm.
Awesome. And so, yeah, I just want to make sure everybody is aware of that, and, you know, say it 3 times, and then people will remember. Go to Oklahoma, be sure to get a copy of the old rubric, because you want to be prepared, and the judges, if you hand the information that's going to answer those questions, the judges are going to be confused. I guess one other thing on that, you all have access to the rubric. Let your students know that, because you all give a presentation at the beginning. I mean, I've seen presentations where they go through and they answer every question that we have, because our questions are outlined based on the rubric. They also have a little worksheet that they can build up now that it's like, if they do everything properly, we don't even have, it's hard for us, because now we have to think of questions to ask, because they've asked every question. And that's a really good problem to have, right? You want to be like, wow, they came in here prepared. We didn't, we had to make up questions for them. So think about that. Come in there prepared and being able to answer all those questions. And it's very, very impressive. All right, so first little section is mechanical design. So you see durability. So what we do with durability is we inspect it for solid construction. We see if there's enough bracing in there, if it looks flimsy, things like that. I mean, like, we like to see a very, very strong support, very strong base, and we want to feel like, okay, if you knock it around a little bit, it's not going to break into 1,000 pieces. And we'll usually ask questions like, does it break a lot? How many times does your attachment fall off? Things of that nature. For mechanical efficiency, we're always on the lookout for multitaskers. So it's, you know, people are always really, really proud of their attachments, but at some point you kind of get a law of diminishing returns. And I'm not saying that you have to do anything one way or another, but if you can get one attachment, like a hook attachment that's very versatile, and it can be operated on like two different missions or 3 different missions, that's a lot more impressive than just having a table full of attachments that are unitaskers that are only good for one specific operation. So that goes into that mechanical efficiency part. If you can really make those so that they're designed to be multitaskers, much more impressive. Let's see here. Also mechanical efficiency, KISS principle. Keep it simple, silly, right? I think that's the politically correct one of those. But that's a very important design principle whenever you're looking at mechanical efficiency. You see these robots and they have, I mean, it's like Megatron, right? It's just crazy. And I've seen some of them where they actually work, they actually pull it off. But more times than not, you have so much complexity, so many moving parts, that if one little thing fails, your entire system collapses. So it's much better, in my opinion, to keep it simple and consistent than to have, like, you know, this huge robot. But I mean, either way, if you get the huge robot and you can make it work, then kudos, right? It's awesome, but it's just there's so many variables there that could break down. Mechanization. So that's basically, appropriate balance to achieve goals and everything. Basically, we don't want to see the robot like popping a wheelie, to get to its location. We want to see that, okay, it's got an appropriate balance of speed and all that type of stuff. We're not breaking things, and it's doing everything it needs to do for the intended task. You're not breaking parts or anything like that. Breaking the various Lego pieces on the board. For programming, this is a big one for us. So everybody really likes to kind of nitpick on the programming side. Programming quality, we want to make sure it's consistent and reliable performance. What that means is basically if I can set that robot down 3 or 4 times and I can say with high confidence it's going to go and complete all those tasks well, then that's great consistency and reliability, right? Usually the way you can achieve that is by good programming standards and incorporating feedback. So they all kind of tie in together. But for instance, they were talking about variability with the board. Well, one way that you can fix, or one of the ways you can mitigate that variability of the board, like the way it's laid out, is to use sensors. So if the might be a little bit off or something like that, you can use proximity sensors and see how far away from the wall you actually are. You can use color sensors, and you can locate what lines are there. You can even follow lines and things of that nature. You can use gyro sensors and have very, very strong feedback of where you've actually went. I mean, on some planes, and I'm not going to digress because I don't have time. On some planes, they can fly around the world and not using any fancy GPS or anything like that, and be off by less than a meter. And that's because of those gyro sensors knowing exactly where they're going, even with headwinds and disruptions in the atmosphere. So I mean, you have a little bit of wheel slip or something like that, then the gyro will help compensate for that. Does that kind of make sense? But so by integrating those sensors and by having straightforward code, it's going to help out with your programming quality and reliability. For programming efficiency, one of the things we really look for, if you want to go back, if you want to be invited back for a lot of the judging and stuff based on programming, you're going to want to use my blocks. That's what we've used. I'm saying this to you all just in all honesty. Whenever we're looking for teams that we want to issue callbacks to for this section, it's, hey, did they use my blocks? That's code reuse, right? That's, if you're not familiar with my blocks, it's like building a function in the code. You build it once, and then you can reuse it throughout your code, so you don't have to keep recreating that same little bit of code. But we look for my blocks. We also look for comments. So very, very important. You wouldn't believe how many pieces of code we see that have no comments whatsoever. And that's like a cardinal sin for programmers. As you're writing your code, you want to document it such that you can have someone who's never seen the code before read through it and have an explanation, right, of what everything is going to do. Now, with that being said, you don't have to write, if you have in the code x equals y, you don't have to write a paragraph of how you're setting that variable. But you want to have comments for anything that's a little bit complicated, and you want to have an overall comment for that subfunction so that whenever we're looking at it, we can read it. And even if I've never seen the LabVIEW code before, I will, or the robot code before, then I'll know exactly what's going on. I'll be able to read the comments and know exactly what you're doing in each section. So those are two big differentiators, my blocks and comments. So please have your students, or recommend to your students to put those in. Another differentiator, although it's not nearly as big, is having that master program. It's really nice that if you can load up all your code and have like a master program that then executes all your subroutines for your different missions. And what that means is, you just have a big menu on top, and it says, okay, I want to run this program, and you can dial down to that program or press the button twice, or you can get creative. The kids get really excited about it. They'll have like little cards, like I saw one of them, and they had like colored blocks, and they had a color sensor, and they would call it the yellow mission, and they would wave the yellow block in front of the color sensor, and it would say da-ding, and it would go off and run that assigned mission that was assigned to color yellow. So I mean, it was kind of neat that they would go through and do that. So I mean, just ideas and stuff for you. Automation and navigation. Again, this is about moving as intended. So this comes in a lot with the sensors, various feedback methods. So we always want to see people use sensors. And if your team is not using sensors, I'm going to say about 95% chance that on their comments section, they're going to say, hey, you could really benefit from using sensors in the future. So really invest and look into using those sensors. I know they can be frustrating, starting to learn how to use them and everything, but they're very, very good. It's very good to have those sensors for feedback control. We talked about that already in programming quality. Other methods, though, for feedback and automation and navigation, you can use jigs. So if everybody's familiar with jigs, it's basically like a big old block or something like that, and you can use it to align the robot properly before you send it off on a mission. They have where you can count rotations of your tires and things like that. So you have all those internal methods as well. If you didn't use a sensor, you could still use like rotational sensors of the motors themselves, or you can use seconds and things like that to figure out how you're going to navigate this board. I put PI control on here just because I wanted to give an example. I had a group of students come through, one team come through, And this was, I think, 2 years ago. And this is before I think PI control got as relevant in this league as it was then. But proportional integral control is a fairly advanced control method, process control method. And these students, they're like, yeah, we're using PI control for line following. And basically what they did was, imagine a straight line, and kind of the non-PI control method to follow that is you say, okay, turn this wheel until you can't see the black line anymore. And then once you can't see it, you turn the other wheel. So you get this like little dancing motion, right? It would go back and forth. It would be pretty pronounced. They used a PID controller to actually smooth that out and make it all go level, and it was nice and no jerk or anything like that. And I was like, okay, this is definitely, their coach wrote this PI control algorithm. But it blew my mind because whenever I questioned the student about it, they actually explained PI control algorithms to me, which is something that you learn like sophomore year of college and engineering. And so, I mean, like it was pretty impressive. But so, I mean, tell the students to go out online, see what other teams are doing. And because they are doing some really advanced, really neat stuff. And the students are really good about sharing those different topics with other teams, especially year to year. So have them look and see what other teams are doing and see what they can take away from that. And yeah, I think that's everything for programming. Strategy and innovation. We talked about this a little bit previously. You can see I highlighted documentation twice. Documentation is the most important thing. We really, really want to have documentation of the design process, the strategy, and the programming. And for the design, for the strategy and innovation, basically the whole idea of the design process. We ask them, how did they come up with their robot? How did you come up with this design? Did you take this design from, say, the Younglings webpage and then modify it to suit this game? Did you come up with this design on your own? We've had some groups of students, they'll break off into teams and they'll each build like a robot, and then they all get together at the end and they see how the robot fares, and then they take the best parts of each piece and make it into their final robot, which is it's a good method, like that upselect method. You can also do voting, and you can also do like an iterative process. So you're designing it and it works pretty well, but then you make little modifications to make it work even better. So, but whatever your process is, we want to make sure that you define that. And if you are using it from another team, we want to know that as well, because that helps you and the other team, that you're having that cooperation or whatever it's called, where you're trying to make everything better. Mission strategy. We talked about this before as well. We want to have a documented mission strategy. So we want to see why you're running the missions you're running and how you selected them. And again, being close to base, that is a strategy. It's not a very, not the best strategy, but it is a strategy. But then when we start incorporating points and difficulty, grouping missions based on using a single attachment, and also pathing, I mean, that really starts to say, wow, these students have really thought about what they're wanting to accomplish here, and it makes it much more impressive. And then innovation, we always ask, what's the most innovative part of your robot? I mean, you see all kinds of stuff. Like they were talking, the ref over there, Derek, was talking about, he's just telling you the rules. He's not going into detail on anything. That's because that's a point, or in my opinion, that's a point of innovation. We had one, I think it's like 3 years ago, there was a bowling, I can't remember what game it was, but it was some kind of a bowling game, and they were supposed to bowl and knock these pins down. Well, the students read the rules, and they said, wow, we don't have to actually roll the ball on the ground. It just says use ball, knock down pins. And so what they did was they set up this catapult system. They ran out, and they just chunked a ball across the table and hit the pins and knocked them all down. It's like, yeah, that's pretty good. And it was like super quick, and all the other teams were like having to navigate this maze to try and knock the pins down. So I mean, like that type of stuff, really make sure you highlight it. What's the innovative thing? What are you all doing that nobody else is doing? And that's not only for robot design or robot, but also in code. If you're doing something innovative with your code, if you're doing something innovative with the design or your strategy. So I mean, like make sure you highlight that so we know. Other items we look for, as with all judging, gracious professionalism. So like if we really like to hear whenever we don't like to hear a team is having trouble, but if a team has a wheel that breaks or something like that, we love hearing that another team helped them out, right? Like, hey, we had a spare motor, let's hook you up. oh, all your code got deleted or your laptop stopped working. We worked with this other team and got them up and running again so they can compete. We really like to hear about that type of information. We want to see that good teamwork. We want to see that people aren't just talking over one another and people aren't shushing one another. People are actually working together on a team and there's good team play there. We want to see demonstration of core values. We want to see a base understanding of concepts, of course. We're going to ask questions about the design and operation and the code, and we want to make sure the students actually have an answer for that. So you can actually go through, and this is something I've recommended to other people. You can get a copy of this rubric, and you can actually interview the students as a practice round, and that way they're pretty well prepared for what questions. Because I mean, we're the same as you all, right? The questions you ask are probably going to be the questions we ask. So that's a really good preparation technique. And we want to see that we like to hear about the most challenging aspect of the competition and how they approached that challenge and overcame that challenge. So what was the hardest thing you did this season, and how did you? Okay, so you saw that was a big problem. How did you approach that problem, and how did you eventually overcome that problem? So we like to ask that question. We like to hear the robot name, because I guess now we don't do the silly award things anymore. But maybe that'll come back, the cheesy award things. But we like to integrate robot names with that. It also really helps us to remember the team, because we see so many teams, especially for like state or international competitions, having a robot name really helps us remember. Oh, that's the team. That's this team over here with that robot name. I guess again, whenever you all do the executive summaries, or if you all did do an executive summary to bring to us, if there was a team picture and or a robot picture, that's super helpful. Because we'll be talking about it between all of our groups, and we'll be like, oh yeah, this team is the one I'm talking about. And the other judges will instantly recognize that team and that robot. So that's very helpful to us. And then also, we always like to hear about the team's experience. So we've had teams in the past that have just kind of blown our minds. It was like they did so well, but they weren't able to hit the highest mark, right? They weren't able to get the Champions Award. But then we find out they're a rookie team, and it's like, wow, that just that turns everything on its ear. So if you do have a rookie team, or if you have a team that's overcoming a great obstacle or something like that, let us know, because there are considerations for that. Some other resources I'm not going to get into, but Dr. Cassidy said he was going to send you this PowerPoint. I've embedded these PDFs, and I'll just open them real quick, just because I'm not going to use up everybody's time. But this is an engineering workbook, and let's see if I can break Dr. Cassidy's computer with this. All right. So the engineering workbook. So that's right. Yeah, I stole that picture, but it has like a guideline for you of how to keep an engineering workbook and make it your own, right? Have your teams make it their own, and we usually get in binders for teams that do that. Like the top tier teams will bring in a nice little binder, something like that kind of shows their process. But this is just something to kind of seed the idea. Then we have the actual rubric. So if I can open it. I don't know why nothing came up. I guess because I broke Dr. Cassidy's computer. And then we have the robot design summary. There we go. So if you all, is this required now, Dr. Cassidy?
It would not. It is. We haven't decided to require it.
Okay.
But I think it's going to be something that the judges have in their hands.
Okay, we'll have it in their hands. Okay. Well, I mean, like whatever you can give the judges to have this information. This I did think was a little bit too detailed, because they had like every mission laid out and attachments and all that stuff. But I mean, this type of information is just huge to a judge. You hand a judge a packet like this, it's like all my questions are answered. How's the weather, right? And we'll come up with questions, of course, in our 5 minutes. But I mean, like having all this information really conveys that the team has thought out like all aspects of the robot design portion of it. But it goes through and tells you the design process, has a table for sensors or for various missions and things of that nature, has your pathing diagram so that you can actually write out your paths. And yeah, it's just a lot of, basically what I'm getting at with robot design, documentation is king. So if you can give us documentation, we'll be very happy, and it makes it look like a very strong presentation. So I think I'm out of time now. So any questions? Does anybody have any questions on this? Everybody stay awake for the whole thing?
You said we're gonna get that, right?
I believe so, unless Dr. Cassidy nixes anything.
Which piece, the new rubric or the?
The PowerPoint that I have,
Yes, absolutely. Yeah.
and I have those PDFs embedded in it.
2 of those PDFs are already publicly available, the first and the third.
Awesome.
On the website. But all the PowerPoints from today, I'm gonna try to share those in some efficient way.
Awesome. Does anybody have any other questions?
Thank you.
I explained it that well, huh? No other questions.
You really did. You really did.
All right. Thank you all.